Tyagarajan sir, can you please allow me to share my screen?
Yes, sir.
Thank you. Sure. Is everybody able to see my screen?
Yes, sir.
Okay. So we'll just quickly go over what we went through last week. We looked at the CIA triad, what does confidentiality, integrity, and availability means. Again, confidentiality is about protecting information from unauthorized access. Integrity means to prevent information from being modified. Availability is to ensure data is available or information is available whenever you want to work on it. So we were going to see the different subtopics under each objective, and we covered both privacy and encryption. Under privacy, we talked about what's personally identifiable information. We talked about protected health information and why it's important for you to keep in mind about the value of your private information, what steps you need to take in order to keep it private. And we discussed about the various privacy laws, both in India, the EU, and USA. Then we went on and we talked about encryption. So within encryption, so we looked at both symmetric and asymmetric encryption. Does anybody have any specific questions, or should I just go over it once? Okay. So we looked at symmetric encryption, which is also called a shared key encryption, where both encryption and decryption is done by a single key. We looked at the different types of algorithms, stream ciphers and block ciphers. Looked at examples: AES, 3DS, triple DES, IDEA, Blowfish, Twofish, RC5. So just keep in mind about the names, right? So when you look at AES, then you should be able to identify that it is a symmetric key algorithm. And what else did we look at? So we looked at its advantages, its speed, and the disadvantages, how to figure out a way of sharing the keys. When we call it a shared key encryption, it doesn't necessarily mean you'll be able to actually pass on the keys, in plain text or over the internet. So in order to figure that out, we looked at asymmetric encryption. So asymmetric encryption is a method by which you share the symmetric keys. So we looked at what's a private key, what's a public key, and how they operate in pairs. So we worked out all the scenarios when A needs to talk to B, and only B should be able to decrypt the communication. What key should be used? Here in that case, in the scenario one, it's B's public key. And in scenario two, where A needs to prove that he or she is the authentic source, what key should be used? Anybody? A is private key, so that B will be able to decrypt it. So we looked at the key exchange mechanism, we looked at certificate authorities, and we looked at the different algorithms. All right. Any questions? Okay. So I'll just briefly talk about certificate authorities. So when we looked at the RSA key exchange mechanism, I told my computer will be verifying the authenticity of the digital certificate my bank's website provides with a certificate authority. So when I mentioned that, there are different CAs, I'll call them CAs. how does my computer know which certificate authority to trust? Because there are multiple certificate authorities, right? And the certificate authority is kind of the source of truth, which says, which bank's website is true and which is fake. Anybody has any idea how does my computer know which is a valid certificate authority? I'll show you. So you have what's called a local certificate store on your computer. So in Windows, you can type cert manager.msc and it'll automatically give you the option to select the console. So if you look into this, so I'm going into trusted root certification authorities. So this is the list of all certificate authorities my computer trusts. So these people will be able, when a certificate is provided or certified by these authorities, my computer knows it can trust the website it is accessing. So if you have, seen this, sometimes when you go to a website and if it doesn't have a proper certificate authority that you trust, you must have seen that error, right? This certificate is untrusted. Have you seen that error sometimes?
Sure.
Okay, so that's because you either that certificate authority is not on your list of trusted root certification authorities, or sometimes the developer of the website will usually use what's called a self-signed certificate. You can generate that in Windows or Linux. You can generate your own certificate, but that certificate is not imported within your computer certificate store. So your computer will not trust it. Any questions? Okay. So the third concept under confidentiality is access control. So what is access control? Anybody? It's easy. To provide only authorized people access. You have a method of controlling who accesses what information. Okay. So we talked about identification and authentication, right? So identification is a method where you say, who you are. It's professing an identity, whether it is your name, it's your hall ticket ID, it's your student ID. You say who I am. Authentication is a mechanism by which it verifies your identity. The third concept that comes under access control is authorization. So authorization only allows you to do what you're allowed to access. Okay, so within a system, you give certain permissions to certain people. Okay, so access control is a method of modifying or controlling or creating those kind of policies. Okay, let's go to our whiteboard. Okay, so when you talk about access control, you always talk about three things, right? Three entities. First one is the subject. The subject is a person, or it could be a principal ID. It's not always a person who's trying to access things. When you design applications, it might be a service account or an account you create just to access certain things. It could be the operating system accessing a file. So things like that. So subject is the first aspect, and the object is the second aspect. Object is the resource. So the resource which you are trying to access could be a file, could be a memory space, could be a register, things like that. The third aspect is operations. what kind of operation the subject wants to perform on the object. It could be creating something, deleting something, modifying something, or even just viewing a file or a table. Okay. So when you talk about how do you really want to provision access to people, they generally it follows under three overarching models. So we look at each one briefly. The first one is what's called discretionary access control. So discretionary access control model, it says that the system owner or the data owner decides who gets access to a particular resource, right? Because now I own my computer and I own my data, I own my system, right? So I can decide who access my system. So generally commercial products like Windows and Linux and Mac, they are designed based on the discretionary access control model. So I can go to a folder on my computer, and if you have operated on these things, you might know. So I can right click, create properties, right? And I can go to the security tab, and I can possibly add people who can access this particular folder. So that kind of control is given to me by my operating system. So these are its permissions. These are the capabilities. Either you can give full control, modify, read and execute, list. There are several things which I can do here. So these are the operations that the operating system allows me to perform on my files. The second type of access control is called the mandatory access control. This type of control is usually used in governments, the military, where the level of access is decided by the security administrator and is enforced by the OS. The user does not have the ability to define who has access to a file and who can modify a file. Okay, so every component, every file within a mandatory access control model is given a label. So with the military, it usually is top secret is the highest confidentiality, and secret, confidential. So there are levels. So whenever somebody produces an information within this model, they have to assign a label to it. So when you assign a label to it, the operating system automatically enforces security decisions based on the label. So when an object is classified as top secret, only people who have top secret clearance can access the object. Got it? It is not decided by the person who creates the top secret content. So a person who has top secret, then we would assume, right? Okay, he has top secret clearance. Will he be able to access confidential layers below it, right? Like secret and confidential or unclassified information. Because top military generals, you might assume, has access to all the information underneath them. But usually that is not the case. They might have the clearance, right? They might have the clearance to access top secret documents, but for accessing any other levels, they have to possess what's called a need to know. Okay, so they have to have a valid reason to access classifications below their clearance level. Understood? So there are a couple of operating systems that were designed for these purposes. One is SE Linux. The second one is Trusted Solaris. You're unlikely to encounter this type of scheme, access control scheme, but good luck if you're in the military. So the third model is what is called role-based access control. So what is role-based access controls? So based on your role within, say, for an organization or a project you're doing, you're automatically assigned certain capabilities. Okay, that's a part of the design of the system or design of your organization. There are several ways you can do it. For example, what I have on the screen is what's implemented in Azure. Azure is a cloud computing platform like AWS or Google Cloud, right? So Microsoft has designed certain roles within its cloud computing platform, and it has automatically given certain capabilities for users. For example, the owner has full access to all resources, delegate access to others. There is what's called a contributor role, where it's not as high as an owner, but it has certain privileges, right? It has certain permissions. Whereas similarly, the reader has certain permissions, but just to view all the Azure resources. They cannot modify the VMs you create, the computing resources you create, right? Then you have a role called user access administrator. So in a big organization, you might have multiple users accessing the cloud. So you might want to govern who accesses what information. So an owner can automatically assign somebody as a user access admin. Say, if, for example, the help desk or support people, they'll be user access administrator. And the server administrator might be in a contributor role. So based on your role, you will have certain capabilities. So that's what's called role-based access control. Got it? Okay. So based on this three models, we have different access control technologies. So technologies are, type of implementations based on all the models we have seen. The first one is like what's called the rule-based access control. So based on certain rules, right? You might define, for example, in your organization, you might be able to access the doors only for certain hours between morning to evening. So that's a kind of a rule-based access control mechanism. Within your routers that route traffic to and fro from different networks, you'll have what's called access control lists. So based on IP addresses, you'll route your traffic in different directions. So that's an example of rule-based access control. The second one is constrained user interface. Let's say, for example, you are using an ATM. You will not have the same type of buttons as what a manager might have, right? A person who's authorized to deposit cash. So they might have different buttons or different interfaces. So you're constraining what a normal user can access and what a privileged person can access. So that's a technology called constrained user interface. The third one is context-based access control. So nowadays, I'll talk about what firewalls are. Firewalls kind of filter traffic to and fro from your network. So they can intelligently filter packets based on different types of application. They can remember the context of the traffic, who originated it and what's the response coming like, and what application is in a session with your computer. So it can intelligently analyze the context around how you're accessing a website or how you're accessing an application, and it can make decisions based on those kind of contexts. So that's what's called a context-based access control. The next one is content-based access control. Even in your home routers, you'll have what's called a parental control, and even within your TV, right? So if there are certain images you might not want your children to view, or they might have a separate logon in Netflix that kind of control what kind of movies kids can see, right? So those are based on content. So this is one type of access control technology. The last one is an attribute-based access control. It can also come under a model. So this is the most recent development. An attribute is when you join an organization, right, you will be assigned a user ID. You might have a location. You might be in a department. You might be reporting to somebody. You might have other parameters defined against you, right? As a person, you belong to this place, or you do these type of job functions. So there are some attributes that are defined against your identity. So you can create intelligent rules against your identity. So we'll talk about what's called an Active Directory. In that, I'll explain how you can do those things. So this is a more complex form of attribute controls, and also it gives you the ability to control a function in a better manner. So it cannot be really simple, right? A person coming in, yes or no. So based on more characteristics that is assigned to a person, you might be able to define complex rules against what a person can access and cannot access. Make sense? Okay.
Yes, sir.
I'm not going into too much depth regarding all these rules because I want to keep it simple for everybody. So you undertake what I'm saying and you go and research these things on your own. You might be able to get deeper. It is not possible for me or even for you, to understand everything on day one. So you take all these concepts, all these names, you go back and read more about them. Then you'll be able to really understand the depth of cybersecurity. What I'm teaching you is like waves on an ocean, right? Cybersecurity is a big ocean. I'm just teaching you the top waves and the water on top. I'm just showing you what's on top. You have to go and analyze what's on bottom, what's on the bottom. It might take you like 3 years to completely master all these concepts. So don't get intimidated by all the terms I use. Just note them down and do your own research and let your brain work on its, work in its own way. And it's just a matter of time before you become an expert. So it's not like, these people cannot do cybersecurity and these people can do cybersecurity. Everybody can do it if you put the time into it. Okay. So we'll look at other interesting concepts within access control. So there is a concept called principle of least privilege. So what it says is only the minimum necessary rights should be assigned to a subject that requests access to a resource and should be in effect for the shortest duration necessary. So a subject must only be assigned rights, just enough rights for them to perform their work, and only for the shortest duration necessary. That is, only for the duration they perform their work. So this is a very important concept you have to keep in mind when you are either in charge of a system or you are developing a software. You should be able to define different privileges within it so that a person like a normal user who's accessing a web page should not have access to all the contents of the backend database. They should only have access to their information and whatever operations they are allowed to perform as a regular user. So if a normal user should not be able to delete all the contents of the database, right? They should only be able to create, probably if you're developing a registration form, they should only be able to input their own details and they should be able to update those details back into the database, right? They should not be able to delete everybody else's information. So you have to ensure only minimum rights are assigned to people that they can do just their work and nothing else. So the next concept is separation of duties. So what this says is no user should have all the privileges necessary to complete a critical business function by themselves. So a simple example, you are going to a departmental store or you are going to like a cloth shop. You might see there is one person writing out your bill of things, right? Then they take it and go and give it to the owner at the cash counter. The cash counter, the person performs the transaction or cash transaction, and he hands out the inventory. So what does this mechanism suggest, right? Two people are doing different things in order to prevent employee fraud, right? If the same person is assigned all the responsibilities, then they might be able to create a fake bill and say, hey, customer paid this, and they might be able to steal the inventory out. In bigger organization, it's even more complex because they might have what's called an invoicing system. There is an accountant, and the accountant is responsible for putting in all the bills, and the accountant hands it out to a different person who's the kind of the manager, and he approves the invoice, and the invoice goes out to the vendor. The vendor pays the bill, and it's received by a different department. So it's called the accounts receivable. And at the end of the day, both things should balance each other. So this is not just a concept, but it is required by certain financial regulations. The same person should not be doing all things. Okay. The next concept is dual control, right? So you might have seen in some movies, right, where there is a critical vault or some nuclear facility, and two military generals, they walk up to it, and one person has to keep his fingerprint, another person has to put his fingerprint, and the door recognizes both fingerprints at the same time, and only then it opens. So that's an example of dual person control. So it calls for two or more people to approve the completion of one function. In a bank or in your organization, if there is a check withdrawal for a very high amount, say like 1 crore or 2 crores, it might require the approval from two managers. So that's an example of a dual control. It also prevents fraud. I mean, two people can, collude and plan and do some kind of fraud, but dual person control makes it kind of difficult to do these things, because the more people involved in doing a sensitive business function, the more difficult it is to talk to each other and make sure everybody's on the same line. You might have seen this in movies, right? When thieves do something, kidnap someone, or somebody always has this dual mind, and they might go around and do a different thing, and does not work well with the group. So what's the difference between separation of duties and dual person control? Anybody understood the differences? Here also you have two people, here also you have two people. Anybody? Okay, so with separation of duties, you have multiple functions, and it says, different people have to do different functions. With two-person or multi-person control, it says one business function, and many people have to approve to do the same function. So separation of duties, different functions must be performed by different people. Here it says one critical business function must be performed or approved by two people. Any questions so far? Okay. So there are a couple other concepts I've not included the text for them. So one concept is called privilege creep, right? It is the opposite of whatever I talked here. So when a person is working for an organization for a very long time, like 20 years or 25 years, over a period of time, privilege creep says a person might accumulate more access than they should. So it's called okay. So when a person works for a very long time, they might get more access than they should need. That's because people trust them. They say, hey, this person has worked with me for a long time. Let him have access to this door. Let him have access to this critical business function. So they tend to kind of accumulate privileges over time, and that increases the chance of fraudulent activity. So as system administrators, as owners of a system, you have to ensure that people don't kind of accumulate access over the years. It's a process challenge. It's not a technical challenge, but it's more of a process challenge to you. One thing that's being done today in order to prevent this privilege creep type of activity is enforce mandatory vacations. So as an employee, you and a mandatory vacation policy states you have to take a vacation for a couple of weeks every year. So what that means is, in your absence, the organization should be able to function. If something goes wrong, people should be able to step in and fix it on your behalf. An organization's function should not depend on a single person being present and doing his work. And secondly, it also identifies fraud. Typically when people try to do some kind of fraud, they will be in the office every day of the week just to make sure that nobody notices what they're doing. So a mandatory vacation kind of takes them out of that position and puts another person in his place, and they might be able to identify if some kind of fraudulent activity is going on. So these are access control models, technologies, policies, and methods to prevent fraud. Anybody has any questions? Okay. So we have covered all components within the confidentiality objective. So we'll go into integrity. So there are a couple of concepts within integrity. One's called hashing. The other one is called non-repudiation. So I'll show it to you really quick. So there are two concepts here, hashing and non-repudiation. So as I told you, integrity is about preserving the information in a way that it says, it's not been modified during transit or during or at rest. Hashing is the fundamental of, for major technology like blockchain today. And, even in transactions, financial transaction, hashing is a mechanism by which you can verify that information was not modified and it's trusted. So hashing is a process by which you take a variable length input and it gives out a fixed length output. The output is what's called a message digest. So whenever you're talking to a server, talking with other computers, a server might create a hash of a file that is sending to you. So the hash information itself is open. So nobody needs to keep that information a secret. So you go into a server and a website and you download that file. And as you receive the file, how do you know that you have received the complete file? Or you have to, in critical transaction, make sure that file was not accessed by somebody in the middle and was modified. You can verify that using a hash. So that because a hash is, it's available, you can compare the hash of the file you downloaded with the file on the server, the hash of the file on the server. And if both hashes match, you can 100% trust that the file wasn't modified and it was completely downloaded. Okay. Any questions about the concept? Okay. So there are, before that, let's look at an example. So this is a website that I can use to generate hashes. I told hashes can take any length of an input and produce a fixed length output. So I typed in hello. So this is the hash output for hello. Word. So the content of the hash changed, but if you look at it, the length doesn't actually change. That is true for all the hash types. Taking me to a different website. As I type, you can look at it, right? The output length does not change. Okay. So what are the properties of a hash? So hash should be one way. So which is to say that given a hash, you should not be able to work back and find what the input is. Of course, there are known hashes, right? For hello. So this is always the hash for hello, right? Because hashes are public, you must be able to say this hash corresponds to this string. That is workable, right? So there is a plain text and there are the hashes. Given the plain text and the hash, you should be able to compare both and say what it is. But you should not be able to work backwards just from the hash. You should not be able to just look at this piece of string and say this is the kind of, and compute backwards and say this is the kind of text that it generates. So that kind of pattern analysis should not be possible with the hash. Is this concept clear? Okay.
Yes, sir.
Next property is to say changing a small amount of the input should significantly change the output, which is to say, if I type in a small exclamation mark, right, you will see that the hash changes completely. Is there any relationship between both these strings before and after I change it? It is impossible to find out a pattern. Okay. So a small change in input should significantly change the output in a way that a person cannot do cryptanalysis on a hash and figure out what is the pattern of your strings, right? This is critical in financial transactions because hashes can travel publicly. You should not be able to just get the hashes and compute things backwards and say, okay, this is a financial transaction that came through. Okay. The next property is, given a sufficiently long input, it should be difficult to find collisions. So what is a collision? So two different plain text should not produce the same hash. That's when a collision occurs. So that will entirely blow up what hashing is, right? A unique piece of string should produce a unique piece of hash. Two different strings should not produce the same type of hash. Okay, so then you might get confused. Okay, what is the correct plain text that produces this hash? Got it? Okay, so there are different types of hashing algorithms. So MD5, SHA1, SHA2. MD5 is depreciated. SHA2 is the most commonly used hash algorithm these days. So there is no key concept within hashing. So the algorithm itself generates a certain message digest with a certain bit length. So what you have here is the bit length. So SHA2 is usually considered a very secure hash. That is, that has all these properties. It's difficult to find collisions. Changes the output significantly, and it's one way. Given just the hash, you should not be able to figure out what the input was. Any questions so far? Okay. So within hashing, there is a technology called HMAC. So it's hashed message authentication code. Sometimes you want to verify that the message was not modified and also make sure it was authenticated, right? It also makes sure it was encrypted. Okay, so HMAC can be used to verify that information. For example, when you create a message, you create what's called a message authentication code, right? So the message authentication code is signed by a shared secret key. So it's just symmetric encryption keys, right? So both the subject and the recipient, sender and the recipient, will have the same key. So when you sign that message authentication code, your message authentication code is your hash. So you sign that using a shared secret key. So when the recipient receives it, for one, they can unlock it or decrypt it because they have the shared secret key. So they can be certain that this was a encrypted communication, right? So because both of you have the same key. And the second one is when they decrypt it, they will get the message authentication code. If they look at the message authentication code, this is essentially the hash. So they will know that the message was not modified. Got it? So how do you implement non-repudiation? So non-repudiation is a situation where a statement's author cannot successfully dispute its authorship or the validity of an associated contract. So when you receive a message or an email, the sender should not be able to say, I did not send it. So that is critical for investigations and other things where critical business transactions, where a person should not be able to say, I did not do it. How do you implement something like that using a technology? So that again comes to preserving the integrity of information in a way that the subject cannot say, I did not do it, or cannot repudiate the authorship of the content. So the method is called digital signature algorithm. We have already looked at this concept in a asymmetric encryption. So what you do is you create a message and you hash it through a hash algorithm and you encrypt it using your private key. Okay, what that does is it actually signs your message. It's a concept. So when you hash something and you sign it using a private key, you are creating a digital signature. When the recipient receives it, right, they will be able to decrypt it using your public key. When they decrypt it, they will get the hash value. So they can compare both the hash values and can be certain that the message wasn't modified. Any questions? Okay, so difference between DSA and HMAC, right? In HMAC, you're essentially doing the same thing, but you're using a shared secret key. And here you're using the public-private key pair. Because you're using a shared secret key, while it can give you some kind of authentication, right? So that you know that you have shared this key with another person specifically, but it does not give you non-repudiation. Okay, it provides some kind of authenticity. It does not provide complete authenticity because it's a shared key. You cannot successfully or defend this in court saying, no, I didn't create this key, or because it's shared, you could have fraudulently done something in a way that the recipient could have fraudulently done something in a way that it make it seem like the message originated from the sender because it's a shared secret key. Here, it's not possible because the private key always is private. And by the fact that you are able to decrypt that information using the public key, you can be 100% certain that the information was sent by this person here because the private key is always private and known only to the sender. Got it? So this concept, digital signatures, you might have seen when you download your Aadhaar card. Has anybody done it? You can go to Aadhaar website and download it. And you'll have a digital signature field. And when you verify it, it will show it was digitally signed by the Unique Identification Authority of India. Okay, which is to say that this number and the information associated with it, the Aadhaar number and the information associated with it, this document is authorized and signed by UIDAI. So it wasn't, something that you created. Got it? Anybody has any questions about hashing and non-repudiation? Okay. So before moving forward to availability, I just want to briefly talk about encryption laws. We looked at privacy laws. I just want to talk about encryption laws very briefly. Encryption is unbreakable with today's computing resources without the actual key, right? Because of that, it's a big headache, of course, to law enforcement. And the governments in various countries have some kind of a law that regulates encryption. In India, for example, they try to implement what's called a national encryption policy, with all kind of clauses where it says user has to have 90 days worth of information on his device, that in both in plain text and in ciphertext. It required service providers to to talk to the government and kind of decide on how they're going to handle decryption and all those things. Those kind of things are against what's called, of course, privacy, right? So as an individual, you will want to keep your information secret, and the Supreme Court later has recognized privacy as a fundamental right. So you're allowed to do encryption, but in a way that is the government can decrypt it, kind of drives people and companies nuts. So when that policy was put out, a lot of people were against it, and eventually it was rolled back. So India, as Indian government, is kind of finding it difficult to build encryption in a way that it ensures privacy, and also it can help law enforcement detect illegal and criminal activities. This is not just a challenge for India; it's a challenge for all the governments in the world, because criminals are able to develop and use all these encryption technologies. The algorithm itself within encryption are transparent, right? You can go read a book and find out what is AES all about. It's not a secret, but the output of the algorithm is what's the problem, right? You cannot go back and find out what the plain text is without the key. So when criminals are using encryption all the way, governments are finding it difficult to get ahead of criminal activity. So encryption policy within India remains confined within different sectors. RBI has its own encryption policy, and DOT has its own encryption policy. But this is like really old, or 40. The DOT says internet service providers can only use 40 bits of encryption with RSA. So what's the industrial standard? Like it's 2048 bits. But 40 bits, it's easily breakable. And you must also have heard of the fight between WhatsApp, Facebook, and the government. WhatsApp introduced what's called end-to-end encryption in its platform, and there were incidents of mob violence where fake WhatsApp messages were used to beat up people and lynch people. The government went back to WhatsApp and told, hey, we want to know who is sending all these forwards. And WhatsApp basically said, we have end-to-end encryption in place. We cannot go inside encryption and figure out who's doing all this thing. That will break the whole principle of encryption. And that's caused a lot of court cases. And the government is now trying to come up with regulations with IT rules 2021. And it was, I think, released during February this year. And it defines regulations for platforms like WhatsApp, Facebook, and they say, you people must be able to cooperate with government in case we require the ability to trace an information back to an individual. You have to put in mechanisms to be able to trace the source of a message. And they are trying to hold what's called these intermediaries. So Facebook is essentially saying, okay, they are intermediaries. They don't hold control over which user posts what content, right? Because it's essentially a conversation between users. Facebook is just an intermediate platform. The same goes for WhatsApp or anything. They are saying we cannot be held liable for two people having a conversation. They are just intermediaries. But government is saying, as intermediaries, it's your platform. You have to be able to cooperate with law enforcement at the time of a subpoena or investigations. So this remains a very complex topic within the cybersecurity community, the people and the government, the companies. People want their privacy, and the cybersecurity professionals want to make sure the principle of encryption is not undermined. They want to make sure encryption stays how it is. For companies, they want your data. They also want to make profit off of privacy. They say they will implement these end-to-end encryption technologies so that people will buy their products. They're making privacy a marketable instrument. And law enforcement wants to be able to look inside communications to prevent crimes. So there is all this conflict that's going on. So it'll be interesting to see what comes out of it. It's not no country has figured out a proper encryption policy or encryption law. Any questions so far? Okay. We'll briefly look into availability. So that's the third concept. I don't know why these concepts are taking so long. I thought this whole presentation is going to be just 1 hour, but it's going into multiple sessions. I hope you can understand all these concepts. Let me know if you have any questions. So redundancy is a concept within availability. Anybody knows what the term redundancy means? Anybody?
So backtracking, sir.
Sorry?
Backtracking, sir.
Not backtracking. Redundancy is a concept of making sure you have a backup plan, right? Every time you make a plan, you have a backup plan, right? You have, when this works, this doesn't work, I have something else to do. So redundancy is implementing backup plans into your system design. Okay. So if one component fails, another component should take up its work. Got it? See, availability concepts are really easy to understand. Unlike encryption or hashing. So those are kind of difficult concepts to understand. But in real time, in real life, those concepts are really easy to implement. You have code that, you have libraries, packages that can do these functions really easily. You don't have to know how encryption works, the background, how all the blocks are configured. You don't need to know all those details. The code will do its abstraction. You just have to call the code within the software you develop, and it will do the encryption process for you. Redundancy, availability, backups, patching, all these concepts are really easy to understand. Right? It's not complicated, but it kind of is really difficult to implement in real time. One is because of the cost involved in building redundancy. Now, second is processes, and you have to make sure you test your processes. Then there is a people are always resistant to change, and when you ask them for what are your redundancy practices, they might say, okay, this is costing so much, I don't want to do anything about it. But when there is a flood or a hurricane, they're left out. So it's a really difficult concept to kind of implement, but quite easy to understand. So when you talk about in terms of big level and higher levels, you'll have data centers, right? Data centers are buildings which essentially house your critical data, and that's where all the processing goes on. Be it cloud computing, Google has its own data centers, Microsoft has its own data centers, and some organizations will have their own data centers, like the private clouds. So they have their own data centers. They host their own servers. They host their own networking equipment. All the processing takes place in the data center, and people essentially, talk to servers inside that data center. So when you talk about processing business critical data within your data center, you have to ensure there is a backup plan for it. So if something goes wrong with your primary data center, so I call them sites over here, right? When you have a primary site, as an organization, you must also have what's called a disaster recovery site. Okay. So that when your primary site fails for some reason, flood, bomb blast, or whatever, right? Your disaster recovery site must take over that function in some ways or the other. We look at it. So there are usually three types of disaster recovery sites. So the first one is what's called a hot site. The second one is a warm site, cold site. Third one. So the hot site is again a secondary location, but it has the same level of connectivity, equipment, and functionality as the DR site. So everything is a mirror of the active site. So when the primary site fails, a hot site will be able to pick up within minutes or hours. That's all it takes. So all equipment is mirrored. So what is the disadvantage of it, of a hot site? Anybody? It's expensive. To be able to create, when you purchase something, you have to purchase the same component to place it on your hot site, right? So it doubles your cost. So to have a hot site is really expensive, and you must put a lot of thought into what components must be a part of your hot site, what business critical processing must be a part of your hot site, and accordingly plan your development of it. The second option is a warm site. So a warm site is kind of in between a cold and hot site. It has all the equipment and connectivity, but it's kind of inactive. It doesn't do a lot of things. It's not like an exact mirror of things. So it has all the required things in place, but it's not active. So when the primary site fails, you have to make sure you activate all the components and the equipments within your warm site. So the outage measured can vary between several hours or days. Warm site is kind of the cost-effective solution between hot and cold. So when you balance functionality and you want to maintain your costs as well, you might go for a warm site. The third one is a cold site. So a cold site is essentially a location. There is no equipment in it, it's just a plain building. There is no connectivity and it's inactive. So when the hot site or when the primary site fails, we'll essentially build the equipment and the connectivity at the cold site. So the outage here is measured in weeks. So these types of buildings, they exist solely for the purpose of, recovering less critical information, right? So when there is not a lot of criticality assigned to business processes that, you don't want essentially to pick up very quickly. So you'll make use of a cold site. Any questions so far? Okay, so I think it's time. So we look at the remaining concepts tomorrow. Any questions? Let me know. If you have any questions now, you may ask. Okay, all right. I will see you guys tomorrow. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
முடிஞ்சா ப்ரோக்ராம்? ஹலோ, அர்ச்சனா மேம், அர்ச்சனா மேம் முடிஞ்சுங்களா? மிதுன்